Exactly. Exactly. Motion is actually a state of a body. When object changes its position with respect to time, we call it in motion. And when there is no change with respect to time in position of object, we call it in rest. And in this way, we define object in two states, either in motion or in rest. That means these two are simply the state of body, state of an object. Like building is a stationary object, you will call it in rest state, because building keep on positioning itself in a particular place. It doesn't move with respect to time. But when you consider a moving car, you call it in motion. And when we consider such an object like car, we actually relate motion with some reference point. Like if you consider a car to be moving, you relate it with nearby objects, maybe a tree, and you consider the movement with respect to that tree. And that is why you call tree to be in a stationary rest state and car to be in motion state. And that is why there comes a concept of a relative motion. Let's say a person is there who is standing side by a road. Now car is moving and two persons are there in car. As a passenger, let's say they are there in car. In such a scenario, those two persons there in car are said to be stationary with respect to each other, and the third person outside is said to be in motion, motion with respect to those passengers or person inside the car. And here if I call the person 1 to be P1, person 2 to be P2, and this person outside is to be P3, then we call these two persons, P1 is rest with respect to P2, P2 is in rest with respect to P1. But if I'm considering P1 with this third person who's just sitting under this tree, let's say, then you will call the person P1 in motion with respect to P3, and similarly P2 in motion with respect to P3. In this way we have a terminology relative motion when we consider frame of reference. Whenever there is motion, what actually happens? Object travels, and when object travels, obviously they will travel some path. If we consider the entire path, the total path that they travel, we call it distance. And if we consider the shortest path that they travel, we call it displacement. In this way, whenever there is motion, there are distances, there are displacements that they travel. And when we consider this distance with respect to time, we call it speed. Similarly, if we consider this displacement with respect to time, we call it velocity. Similarly, if we consider change in velocity with respect to time, we call it acceleration. Similarly, if we consider total distance traveled with respect to total time taken, we call it average speed or average velocity. When we are only given with u and v, the average velocity is simply average of u and v, that is u plus v over 2. And if you are given with same distance traveled with two different velocities, let's say you are given with s distance traveling v1 velocity, traveling with v1 velocity. Similarly, again s distance traveling with v2 velocity, you can figure out the average velocity, that is twice v1 v2 over v1 plus v2. I've explained all these things. I will quickly help you with the revision portion, and I will explain what the quantities are. Then I will start with those different parts, that is distance, displacement, speed, velocity, acceleration, average velocity, and further we will cover equation of motion today. Can you tell me what are quantities and what are different quantities that you know? In this physical world, there are many quantities that we come across in our real life, in daily life, and in physics there are many quantities that we are supposed to study later on and now as well. Can you categorize them? Can you tell me what are those different physical quantity and non-physical quantity and difference in both? Especially what do you understand by this quantity terminology? I want answer from the side. Tell me, Sanket. Yeah, Sanket, are you able to listen to me? I want answer from your side. Yeah, sure. Yeah, I can hear you. I can hear you now. Explain them. Okay, Sanket. Uh, what do you understand by these quantities? Tell me. Okay, no issue. I'm going to explain it again. You don't worry. Whenever we consider different quantities that we come across in our real life, actually there are two type of quantities that we come across. The first are those which are measurable. For them, there are some instruments available, and that is why we can measure them. Like if you consider temperature to be a quantity, let's say you are suffering from fever. I'm not expecting that, but let's say we are suffering from fever, then there are instruments from which we can measure the temperature, that is thermometer. Even if temperature is so high, like the temperature of any burner or any uh, other objects, we can measure them using pyrometer if they are so high. And we have many devices to measure temperature. Similarly, we have devices to measure mass, we have devices to measure time, we have devices to measure electricity. And when we consider such a physical quantities, such a quantities that are measurable, we call them physical quantities. That means quantities which are measurable are physical quantities, and there may be some quantities in our real life that we can't measure. Let's say someone is suffering from a lot of pain. You can't measure their pain. If someone has other emotions like love is there, sorrow is there, happiness is there, you can't measure them all. That is why you call them non-measurable quantities, and such a non-measurable quantities are non-physical quantities. And that is why the broad category is two broad categories are there in which we can categorize these quantities. The first one is physical quantity, and the second one is non-physical quantity. Can you tell me now what are physical? That can be measured. That has some instrument that we use to measure them. Like you have a speedometer in your scooter, in your car, by using which we can measure the speed of the speed in which we are traveling. Similarly, we have odometer to measure total distance covered. We have ammeter to measure electric current. We have different devices to measure weight. We have different clocks to measure time. That is why we will consider them all in measurable physical quantities. And all emotions, we can't measure them. That's why they are considered to be non-physical, and we are not focused on these non-physical quantities. They will be part of somehow psychology and those philosophy. We will be considering physical quantity in physics now. Now, if I consider physical quantities, we can again categorize them in two heads. The first one is scalar, the next one is vector. What are scalar? One which have only magnitude are scalar, like mass. Mass has only magnitude. We can't give any direction to mass. Energy has only magnitude. We can't give any direction to energy. Similarly, we have other quantities, like if you remember quantity like distance. If I consider distance to be one of the quantity, you have only magnitude with this distance. You can't have direction with this. Similarly, you have many such quantities like length, any length it may be, length, breadth, height, they all are part of distance actually, and they don't have any direction. That is why we call them distance. Similarly, we don't have direction with speed as well. That's why we call speed to be scalar. But velocity is speed with direction. That's why velocity will be vector. And you need to remember that vectors are those quantities which have both magnitude and direction. Like force is a vector quantity because you apply some force in a direction. Similarly, speed with direction is velocity, that is actually vector quantity. Similarly, displacement is the shortest path covered that follow a direction. That's why you will call displacement to be a vector quantity. In this way, we have distance and displacement to be very interesting thing here, and I will just repeat it again. Total path covered, total traveled path is actually distance, and the shortest path followed by the body or object is actually displacement. As both are related with length somehow, that's why their unit is meter, SI unit is meter, but the distance is only having magnitude, that's why it's scalar, but displacement has both magnitude and direction, that's why it is vector. Is it clear up to this? Is it clear up to this? I want you to tell me. Yeah, okay, alright, fine then. Okay, I'm considering a question for you. Let's say I traveled a distance of 5 meter from my house, this place did this, and now I'm traveling towards south up to point B. I traveled 5 meter and then I turned towards east and I traveled a distance, let's say I traveled initially 4 meter and then I'm traveling 3 meter, let's say, and I reached up to point C. I traveled from A to B, then B to C. Can you tell me what is the distance that I followed in this journey? And what is displacement that I had in this journey? I want the answer from your side. Tell me the distance traveled and displacement followed in this journey if I'm traveling from A to B and then B to C. Yeah. Yeah, take your time and tell me answer. Yeah, exactly. Distance is actually the total path traveled. And here if you follow the total path traveled, it's going to be how much? It's simply 4 plus 3, not out at all, and that's coming out to be 7 meter, the total path traveled, which is your distance, isn't it? Yeah. Can you now tell me what is your displacement? How will you figure out the displacement? Yeah, A to C directly, that is shortest path. Yeah, that means you need to answer, you need to figure out this value A to C. This length you need to figure out. Do you have any formula to answer to find out this distance AC? What will you use? What will you do to answer this? How will you able to answer this? Yeah, there is a formula known as Pythagoras formula that tells the way to figure out such a length. Let's say if you are given with a right angle triangle with one angle 90, then you have the longest hypotenuse which is just opposite to right angle. Here AC is the longest length, which has a relation like this. Length hypotenuse square is actually equal to square of other two, sum of square of, okay, we will take sum of square of other two legs here. In this case, AC square is going to be equal to AB square plus BC square, that you will get is 16 plus 9, That means 25 is the value of AC square. Now if you want AC, you need to take a square root both side and you will get 5 as the square root of 25. I think you must be able to figure out this now. 5 meter is your displacement, whereas 7 meter is your distance. And this is very interesting thing, that displacement is always either greater or equal to distance. Displacement can't be less than distance. They can either be equal or can be, displacement can be 0 as well. Let's say you started traveling from this point, you goes up to B, then you goes from B to C, then you goes from C to D, and again you came back to A. Let's say you are traveling 4 meter, then 6 meter, then 4 meter, then coming back to 6 meter. Can you tell me in this case what is distance and what is displacement? We have started from A, then goes to B, then B to C, then C to D, then D to A. It started with A and came back to A. Yeah. This rectangle, very good, very good. Yeah, it's a rectangle. Yeah, very good. Yeah, tell me answer. I think you can answer. Actually, you need not take a square. You just need to add up them all. Perimeter is simply, yeah. Very good, very nice, very nice. 20 meter is your distance and 0 meter is your displacement as you came back to the same point. That is why displacement is 0. It's nice, fine. Okay, similarly here we have a question in which we traveled from A to B, then B to E, then E to C, then C to D, then we came back up to E. Again, if you want you to find out total distance, you need to add them all. If you want displacement, you need to consider A to E only, that is 25. Displacement is 25. Similarly, we have already covered this one. And now I'm going to help you with quick revision of what we have covered so far. Whenever there is motion, we come across distance, displacement, speed, velocity, average speed, average velocity, and acceleration. I'm just going to help you with this revision. You just keep on the track. Distance is total path, unit is meter, it is scalar quantity. Displacement is shortest path, unit is meter, and it is vector quantity. The speed is distance over time, or simply you can say rate of change of distance is speed. Its unit is meter per second. Velocity is displacement over time, its unit is meter per second. Speed is scalar, but velocity is vector. Again, average speed has the same unit meter per second. It is simply total path over total time. Okay, its unit is meter per second. I have indicated here, you don't worry. They all have the SI unit meter per second. Whether it is a speed or velocity or average speed or average velocity. Then average velocity is simply u plus v over 2. And one more thing is there with average velocity. If you travel same distance, let you travel x meter from A to B. And again you travel x meter from B to C. But initial distance you traveled by using v1 velocity. Next distance you are traveling with v2 velocity. Then average velocity or average speed is going to be twice v1 v2 over v1 plus v2. It has been obtained from this formula itself. You don't worry. If you put in this formula, you will get this result. But if you remember this result, it will help to solve the question quickly. That's why I will suggest you to remember this. Twice v1 v2 over v1 plus v2 is your average speed or velocity. If you are given with initial velocity and final velocity and you want the average velocity, you can just take the average u plus v over 2. Acceleration is simply rate of change of velocity, that is v minus u over t. Let's say you are traveling with velocity u and you gain velocity v in time t. then this figure can be represented in this way. And from here, there comes the concept of average velocity, which is u plus v over 2, comes the concept of acceleration, which is simply v minus u over t, or simply v over t. The SI unit is meter per second square for this acceleration. If we consider such an acceleration with respect to this earth, that means gravity, you call it acceleration due to gravity small g, and for earth's surface it is coming out to be 9.8 meter per second square, that you can remember, which is simply 10 meter per second square in approx. And you will be using this when you solve the question based on gravitation later on. Okay, I want you all to remember these important 8 points before you start with some other questions. And then we have some more concept number 9, which is related with conversion. Here you can convert kilometer per hour to meter per second. Further, you can convert meter per second to kilometer per hour. If you want to convert kilometer per hour into meter per second, you multiply by 5 over 18. If you want to convert meter per second into kilometer per hour, you just multiply by 18 over 5. Then we have 10th concept, and I want you to write it as equation of motion. There are 3 equations of motion that help us to solve any uniform motion related problem. There are 3 important things here. If you remember this point, that you move with velocity u and finally acquire velocity v in time t, then acceleration then acceleration is simply v minus u over t. Further, if you solve this, you will get at is equal to v minus u. Further, if you shift u here, you will get u plus at is equal to v. Actually, this is known as your first equation of motion. Similarly, if you use this concept of average velocity, you can answer the third and second and third equation of motion. Second is s is equal to ut plus half at square. This is a, remember. And third is v square minus u square is equal to twice as. I want you all to remember this 10th point as well. In this way, there are 10 points that I have helped you with today in this class. I want you all to remember these 10 points in this chapter. All the questions that we will be solving are based on these 10 points. I'm going to help you with all these 10 points once again, so that if you want to write, you can write them all. Just go through them. Distance, total path traveled, SI unit is meter, this is a scalar quantity. Displacement, shortest path, SI unit is meter, this is vector quantity. Speed, velocity, average velocity, they all are having unit of speed itself, that is meter per second. And if you consider speed, it is simply rate of change of distance, which is distance over time. Velocity is rate of change of displacement, which is displacement over time. Average speed is simply total distance over total time, and average velocity is u plus v over 2. Acceleration is rate of change of velocity, that is v minus u over t, or simply v over t. Average velocity, if you are given with the same distance but you travel with different velocities, you use the formula twice v1 v2 over v1 plus v2. 9th point is when you want to convert kilometer per hour into meter per second, you just multiply by 5 over 18. And if you want to convert meter per second into kilometer per hour, you just multiply by 18 over 5. And if you consider this Earth's surface as your object, you have different masses lying on this surface, and these are attracted towards Earth with a force, and we call this force to be gravitational force. And when we consider this force in our picture, actually whenever there is force, there is acceleration. And here we consider acceleration to be there with respect to this Earth, or due to this Earth. That's why we call it acceleration due to gravity. If you just throw an object, not throwing, you just dropping this object, like I'm dropping this pen. If you are dropping these objects You are only dropping it. You are not you are not applying any force. In such a case, there is a force which is applied itself, which is called attraction force of the gravitation. And that is why there is acceleration, which is acceleration due to gravity, which is small g, that is different at different places, but for Earth's surface it is 9.8. For other planets, like in some planets there is no such environment, there is no such uh, gravitation. But in case of moon, this gravitation is very 1/6 of this gravitation of Earth. That is why the attraction for objects on moon surface is going to be lesser as compared to that with Earth. Okay, and then we have equations of motion that help us to figure out different parameters, like if you are given with v, u, t, you can find out a. If you are given with v, u and a, you can answer t. Similarly, you have s is equal to ut plus half at square. If you are given with u, t and a, you can find out distance traveled. Similarly, if you are given with v, u and a, you can find out s. In this way, these relations help us to figure out these parameters. I think you are okay up to this. Have you written down all these points? Let me know this first. I want you all to remember and note it down. Sanket, you let me know that, whether you have written it or not. These 10 points, yeah, almost you have written. Do take your time and write it. Because they all are going to help us solve many numericals based on this motion chapter. If you want derivation of these all, equation of motion, I will tell, but I think they are not that much in your syllabus. They must be, their small portion is there in your syllabus. We can actually mathematically prove them, that I have done for the first equation of motion, or you can graphically prove the equation of motion. I will just introduce it briefly and then we will be solving many questions today. If you have written it, please let me know. I will continue with these numericals. Okay, you are done with this. Okay, that's fine. In previous class as well, we have converted 36 km per hour into meter per second, that we got here. We have converted 30 meter per second into kilometer per hour, that you can obtain using multiplicand this 18/5 that we have done. Then we have graphical explanation. Let's say you are moving here. At this point, you are indicating y-axis with velocities, and here x-axis represent time. Then this point is u. Here you, when you move up to this, you find here v. In this way, you moved from A to B. That means you gained velocity v. Let's say it takes time t. That means you gained velocity v from u to v in time t. And that is why this BC over AC, this BC over AC simply indicates velocity over time. And change in velocity over time is nothing but acceleration. That is why we will call it acceleration. V minus u over t is simply, this parameter is simply acceleration. Acceleration is also slope, which is simply perpendicular over base. What is slope? If you consider this to be theta, slope is simply perpendicular, that is BC over base. Oh, sorry, not BC, here BD over AD. Simply BD, I have to write BD here, and AC, BD over AD. BD over AD, which is B minus U upon T minus 0, which is B minus U. And this is actually acceleration. And that is why it becomes V is equal to U plus AT, first equation of motion. Now if you want the second equation of motion, you need to consider a very important thing. We want displacement, distance traveled, and that is why you need to consider area And when we consider area, it is the formula that we remember. Here we have triangle and we have this rectangle. The triangle has area half base into height that I have used here, half BC into half BD into AD I should write, and then OD into this is length into breadth, that is AD into OA into AD. AD into OA I should write. AD is simply T, OA is simply U, and I can write all these here as well. That is coming out to be UT plus half V minus U into T. In the place of this V minus U, I can write AT that you see here, and that I have written here, and it become half AT square, and that is finally we got UT plus half AT square. So interesting. And here the important thing is displacement is simply area under VT graph. This is a note you need to make. If you are drawing VT graph, the displacement is area under this VT, velocity time graph. That is your, you figured out entire area. This is the second equation of motion. In third equation of motion, what you are doing is you are considering area again, that is half sum of these parallel sides, that is U plus V, and multiplication of distance between them. This is area of trapezium. Do you know the formula of area of trapezium? Sanket? Let's say you are given with a trapezium like this. What is formula that we use? Do you know this? Yeah, half sum of parallel sides, that is AB plus CD, and distance between these parallel sides, let's say it is H. Similarly here we are using same formula. Sum of parallel side OC, parallel side are OA and CB. Here we have used OA and CB, OA and CB. It's not BD, it should be CB. Yeah, somehow it has been, there was a mistake here. And then distance is AD actually. OA is nothing but U, and CB is nothing but V, you see here. And this AD is nothing but T. And now we want to put the value of T from the first equation. What you get from first equation? T is simply V minus U over A. V minus U over A. You just put here. And I'm doing so, V minus U over A. You just see here. I'm just substituting. And I will get V square minus U square upon 2. And further, if you shift A towards here, you will get V square minus U square is equal to 2AS. This is your final equation. In this way, you get all these three equations of motion that I have mentioned here, and I want you to remember. The first one is V is equal to U plus AT, second one is S is equal to UT plus half AT square, and third is V square minus U square is equal to 2AS. Now we will be solving questions. Start with the first one. Here it is the first question that I want you to solve. I think you can just see the answer question. I'm increasing its size too. Okay, train accelerates from 36 km per hour to 54 km per hour in 10 seconds. Remember, here time is given in second. And initial velocity U is in km per hour. Final velocity is also in km per hour. First you convert them all in SI unit. That is my suggestion. Tell me answer to this. How can you convert your U into meter per second? What will you do to convert it into meter per second? Sanket, tell me. How can you convert 36 km per hour into meter per second? How can you do this? How can you solve this? Can you convert it? Sanket, yeah, here you can observe. How can you convert? Ninth point. If you want to convert kilometer per hour into meter per second, you just need multiplicand 5 over 18. And further, meter per second to kilometer per hour, you need to multiply by 18 by 5. But right now we want to convert kilometer per hour into meter per second. We will multiply by 5 over 18, that we got 10 meter per second. Similarly, can you convert this final velocity into meter per second? Again, you will multiply by 5 over 18. 18 3s are 54. You got 15 meter per second. That means you acquire velocity 15 meter per second from 10 meter per second in those 10 seconds. This is the scenario. From U to V, you came from U to V in 10 seconds. Now if I ask you to figure out acceleration, you know the formula. What is acceleration? Can you tell me that? V minus U over T is the formula to find out acceleration. And V is simply 15, U is simply 10, and time is simply 10. Further, if we solve, it's 5 over 10. That is 1 over 2. Or you can also write it immediately 0.5 if you want. Or you write half, or you can just convert into decimal 0.5. What is SI unit of A? It's meter per second square. This is your answer. So easy to answer. Acceleration, we know it is simply rate of change of velocity, and we are given with velocities. It changes from U to V in time t, and right now it changes from 10 to 15 in time 10 seconds. Can you figure out distance traveled by car? What formula will you use? You are given with U here, you are given with V here, you are given with T here, you are given with A here, you are given with T here. Which formula do you know which will help you to figure out S? If you remember third equation of motion, or you remember second equation of motion, both you can apply here. Even you can apply second equation of motion, which is S is equal to ut plus half a t square, or you can apply v square minus u square is equal to 2as. You just divide by 2a. In both of these cases you will get your S. Now it's all up to you which you want to apply, whether the second equation of motion or third equation of motion. It's all up to you. Which one you want to apply here? Tell me. Third or second? If you apply this third, you will put V equal to 15. You will put U equal to 10. You will put 2 here, and acceleration equal to 0.5. That is 1 over 2. You can cancel them. You got 225 as 15 square is 225. 100 here. You got final answer 125 meter. And even if you use this second equation of motion, you can get the same answer 125 meter. You got this one or not? I've helped you with the entire concept. We have used the first equation of motion here to figure out acceleration. We have used third equation of motion to find out S. Even we can use second equation of motion to find out S. Here we have used equation of motion as well, concept of acceleration as well, conversion as well. This question is so interesting. We have revised all those concepts. That's why I have taken this question, so that we can revise the conversion, so that we can revise acceleration, so that we can revise all those equations of motion. First one is V is equal to U plus AT. Actually you have used this one here. Is it okay for you now? Are you fine with this explanation? Tell me this, Sanket. Yeah. Now you have second question, and I'm presenting here for you. Its answer is here 125. I have already presented answer as well, but I've explained this more clarity. You can just see. Now tell me answer to the second question. It is concept based question. If you have gone through all these concepts till now, you can answer this second question. So easily you can answer. I want you to answer this second question. A body whose speed is constant, a body whose speed is constant must be accelerated, might be accelerated, has a constant velocity, cannot be accelerated. A body whose speed is constant. Let's say a body is moving here. If a body is in rectilinear motion, what is rectilinear motion? Straight line motion or linear motion is your rectilinear motion. If a body is traveling in a straight line, let's say car is traveling here, from here it moves up to here. The car is moving with following this straight path, you call it rectilinear motion. But if some body moves there in a circular motion, in a curved path, in a circular path having a radius, you call it moving with you moving in circular path, you call it circular motion. These are two kind of motion that we consider here in our study. Motion along a straight line, that is rectilinear or linear motion, and motion along a circular path of radius r, you call it circular motion. What actually happen here in circular motion? You move with a constant velocity, but still you have different direction that you follow. And as you follow different directions, okay, you follow different directions, but the velocities are same. And when you move here, whose speed is constant, you are moving with constant speed here. If you are moving with constant speed, what happens? You are performing a motion, speed and time graph goes like this, and velocity time graph goes like this. The velocity is constant. And if you are following position time graph, it goes like this. It's constant. Speed is constant. Whenever you take slope, it is going to give you constant value. Whenever you consider velocity, it is going to give you a constant value. Let's say v naught. Let's say 5 meter per second. Okay, here velocity is constant. Do you think it is accelerated? No, they are not accelerated. Acceleration is zero. Acceleration is zero because change in velocity is not here. Change in velocity is not here. That is why in linear motion, if there is constant velocity, acceleration is zero. Is it clear, Sanket? Let me know this. But what happens if you are moving with circular motion? If you are moving with circular motion, what will you call to? What is acceleration in circular motion? Actually, there is acceleration in circular motion because you are moving and with velocity v you are moving and there is a radius you are following. Here you have acceleration. It moves with an acceleration. It has same velocity, still it has acceleration. That is why it may be accelerated. In circular motion, even if body moves, actually body moves with constant velocity, but still it is accelerated. But in rectilinear motion, it moves with constant velocity, means acceleration is zero. And that is why the answer should be might be accelerated. Why I am saying so? Because if it is circular motion, it is going to be accelerated. That is why I am saying might be accelerated. It's so interesting to understand this. So interesting to understand this. Is it okay for you now? The time that it takes here is total distance. What is time that you know? Speed is equal to distance over time. Time is equal to distance over speed. And here distance that it travels from here to this, it covers 2 pi r. In circular motion, if radius is r, we can figure out, if radius is r, we can figure out what is its perimeter, what is its circumference. It is 2 pi r. We can just figure out what is its area. It is simply pi r square. Right now the total distance that it travels is 2 pi r that we put here. The total speed that it has is v that we put here. This is going to be our formula for the time period that it takes for entire revolution. Okay, this is the condition of circular motion. Here the direction is keep on changing. That is why the constant speed generates an acceleration, and that is v square over r. You remember this. But in rectilinear motion, if object is moving with constant velocity, it doesn't have any acceleration. It is said to be no acceleration. It is said to be zero acceleration. But for circular, it is still accelerated even if it is traveling with constant velocity. Is it okay for you? You got the answer to this second question. And now if you are okay with this second question, I want you to solve this third question. Again, this third question is so interesting for you. Again, this is so interesting for you, and I particularly think that you can solve this. You are supposed to figure out retardation here. Can you solve this? Retardation is simply negative acceleration. When there is a retardation, it means the body is decreasing its speed. Negative acceleration is called as retardation. And whenever an object decreases its velocity, first it was traveling with u 54 km per hour. Now its final velocity decreased to 36 km per hour. If it is decreasing its speed, it means it is that is retardation, negative acceleration, you can say. And first I want you to convert these u and v, then only you can answer. What is your u in meter per second? Can you tell me that? What will you do to find out u in meter per second? Tell me that. You will multiply by which factor? Yeah, tell me. Exactly. It is going to be 15 meter per second. The previous question was quite similar, and here it is going to be how much? 10 meter per second, and time taken is how much? 10 seconds, and acceleration is what? V minus u over t. That means it is coming out to be 10 minus 15 over time is also 10. That is minus 5 over 10. That is minus 0.5 meter per second square. This negative symbol indicates it is retardation. Object is decreasing its speed with respect to time, then there comes retardation. If object is increasing its speed with respect to time, it is called acceleration. Got it that? Yeah, now there is answer to this question that I have presented. Quite easy, quite simple. Negative symbol, negative sign implies that it is retardation. It has been indicated here. Now you have the fourth question, and in this question what is mentioned? A particle is moving in a circle of diameter 20. It is moving in a circle of diameter 20 means radius is 10, because diameter is twice of radius. That is why radius is half of the diameter. And since diameter here is 20, you will divide it by 2 and you will get 10 as your radius in this question. What is distance at and as per the table given below? For one round, can you find out displacement and distance? If you cover one round, complete one round, then distance is total path. Displacement is shortest path. And distance is 2 times pi times r, that is 20 pi. And displacement is 0 because it has been traveling the entire journey and came back to same point, let's say A. That is why I call displacement to be 0. What is distance? And as per the table given below, this is a table, and I want you to figure out these, and I think you can figure out. For one round I have just answered it, that it is 20 pi and displacement is 0. Similarly for another 1.5, I think you can answer. If for entire duration it is 20 pi, for a half journey it is 10 pi, that is why for 1.5 it is 30 pi. I have presented the answer, you can see here. And displacement is going to be how much? What is displacement if it travels 1.5? This is entire, then it travels this much. How you got 20? From here to here. You will take this shortest path. You will not take this path. You will take this shortest path, and that is 20. Got it? Why? If it travels 2 rounds, it is 0 displacement, but 40 pi is your, not 40 pi, but simply 40 pi is your total distance. Similarly, if it travels 2.5 round, okay, you got the answer to all of them. Is it okay for you? Okay, the fifth question, the last question of today's class, I want you to answer and conclude the session today. Tell me answer to this question. A scooter traveling at 10 meter per second speed, 10 meter per second, speed up to 20 meter per second in 4 seconds. I want you to tell me the acceleration. Tell me that, and we will end with the session today. Okay. You just need to figure out U in SI unit. Do you have U in SI unit? You will say yes, because meter per second is SI unit. Do you have V in SI unit? You will again say yes, because it is again in SI. Time is in SI unit? Yes, second is SI unit of time. Everything is SI unit. We have formula to answer it, V minus U over T. And right now I want answer from your side. Tell me what you got. Yeah, exactly. It is simply 20 minus 10 over 4, which is simply 10 over 4, which is simply 5 over 2, which is simply 2.5 meter per second square is your final answer. Very good. It's 2.5 meter per second square. That is your final answer. Okay, I'm going to end with the session now. And there are many other questions as well that I think you can solve later on, and we will be solving in next class too. And if you want to solve this one, I want you to appear this, appear the sixth one as well, and we can apply equations of motion to find out answer to this one. A train starts from rest, that means U is 0, and accelerate uniformly at rate of 5 meter per second square. Acceleration is given to be 5 meter per second square, and this acceleration come in time 5 seconds. Velocity, calculate the velocity of train in 5 seconds. We want V. Which equation do you know in which V, U, A and T are involved? You will say first equation of motion. V is equal to U plus AT. And here V we want, U is given to be 0, A is given to be 5, T is given to be 5, everything is in SI. 25 meter per second is your final answer. So easy. We use first equation of motion to answer. Similarly, I have many questions here that I have for you, but we will solve them all in next class. You can take a screenshot of this question if you want, 7th one, 8th one. With the answer I have presented, 9th, then 10th, then I have 11th, then 12th, then I have presented 13, then I have 14, 15, 16, 17. I presented them all with answer 18, 19, 20, 21. Okay, alright, I'm ending the session for today. You just solve them all, and I think it will help you to increase your knowledge.